the air compressor. The air would go out through this through this red pipe into the heat exchanger. This is the heat exchanger where the air goes in here and goes out of this one. Right? We can also note that this is T3 and this one is T4. As well, water goes into the heat exchanger, cools down the air, so the air goes out in a blue pipe, and then the water goes out from here to the drain. Air would continue into the storage tank, and from the tank it goes out through the blue pipe, through the silencer and to the outside. And you may notice here T7, which is the temperature at 0.7 before the air goes out. So this is a brief description about the operation of this air compressor. Now, usually in our lab sessions, we operate two compressors. The first is that one there, and which we looked at already, and the second one is this compressor. I'm going to give you an idea. This one as well has a very high noise, and it has this screen here. This one is called air compressor 1, and this screen is where you can take your data from. In terms of the components of this compressor, it has the same component as the one we looked at. Usually students in a lab session would have the choice to use any compressor they want, either this compressor, air compressor 1, or that one over here. I'll go up with the speed of this one now. As you notice, it's now about 1,000 revolutions per minute. Now, if we leave it a couple of minutes, we will notice that the temperature at the red lines is already high. Now T2 is about 53.8. But it will keep going up. It needs about 5 minutes to go higher. The most important during this demonstration is to understand this sheet here. So again, it's available in your lab instruction. What we need from these, and after you read your lab instruction, you see that we have different boundaries. Boundary A, which is the air compressor, boundary B, which is the heat exchanger, and then we've got boundary C, which is all of the compressor all together. The input is only the electric power here, and then the water is going in and the air is going into boundary C, whereas the air is going out of the boundary C. Finally, we have boundary D as well, right? So in your lab report, you will see that you need to work with different boundaries. You need to define the inlets and the outlets of these boundaries. For example, in the air compressor here, we've got 0.1 going in and then 0.2 going out, and we have the motor power as well coming in. For the heat exchanger, we have 0.3 going in, 0.4 going out, and then we have 0.5 going in as well for water and 0.6 going out. I will leave the remaining of these issues for you to practice in your lab report. You can start noticing that T2 is now already 66.7. The motor speed is about 1000 again. You need to make sure this value here is a gauge pressure. We need to add into it the ambient pressure for it to be absolute when we use it in our lab report calculation. Much higher now. And this is enough for the recording. Thank you. If you have any questions, you can send me email, or we can arrange a meeting for consultation.